The global economy is entering a more volatile era. Supply chains are fracturing, and nations are scrambling to secure their own technological resilience. To navigate this, the UK government has released the Invest 2035 Modern Industrial Strategy, a 10-year roadmap designed to secure the country's economic future. This chart maps the IS8, eight high-potential growth sectors holding a projected $10 trillion in global export potential. The government has capital ready, but policy documents don't write code. There is a massive execution gap regarding who actually builds these technologies on the ground. Securing the next decade of UK innovation is an engineering and research problem. That physical R&D engine exists at the University of Southampton. Specifically, it lives within the newly relaunched Centre for IoT and Pervasive Systems, or C-IoT. The center brings a 2-decade track record to the table. They've been conducting EPSRC-funded research in energy harvesting since 1999, creating components that generate their own electrical power from ambient sources. This specific history of multidisciplinary hardware and software integration aligns perfectly with the government's new requirements for foundational tech. Make no mistake, C-IoT is perfectly positioned to be the R&D engine that powers the UK's next industrial era. To connect expertise with national funding, C-IoT is hosting 4 targeted workshops. These interlock directly with the IS8 growth sectors. The first frontier is digital and technologies, pushing out into Edge AI, 6G, and satellite IoT. This schematic outlines C-IoT's systems-level approach to next-generation wireless. They are actively developing AI-native networks and finding efficient transmission techniques to enable massive, secure machine-type communication. Secure, massive-scale connectivity has to be solved before any other industrial sector can function. It is the mandatory nervous system for the entire modern economy. The second frontier merges clean energy and advanced manufacturing. Both of these sectors share a critical bottleneck. They require hyper-resilient infrastructure deployed in extreme, hard-to-reach environments. Traditional batteries fail this test. They are expensive, environmentally damaging to dispose of, and physically impossible to replace across billions of deployed industrial devices. C-IoT attacks this with system-level battery-less design. They co-design the sensor and energy harvesting components together, creating devices capable of adapting to their available power supply and operating indefinitely. In practice, this means we can monitor high-voltage smart grids or predict maintenance on the bearings deep inside a jet engine, using only the ambient heat or vibration the machine itself generates. Eliminating the battery bottleneck entirely allows us to achieve true, limitless automation in advanced manufacturing. The third frontier focuses on life sciences, tracking the national pivot away from reactive hospital treatments toward predictive digital health and remote virtual wards. At the micro level, C-IoT researchers are scaling down sensor technology, building devices small enough to detect microRNAs for nanoscale disease diagnostics, alongside smart adhering fabrics that monitor vital signs continuously. At the macro level, they are utilizing secure, federated machine learning. This allows massive datasets of IoT health data to be analyzed locally on the devices, avoiding the cybersecurity risks of centralized data silos. The future of life sciences relies on our ability to embed sensors at the cellular level, while safely processing that data at the population level. The final frontier is defense. As global geopolitics shift, national security has become the ultimate prerequisite for any domestic economic growth. The future defense ecosystem demands 2 things: impenetrable hardware security and pervasive autonomy across all domains. C-IoT aligns with the Internet of Battle Things, engineering secure, self-healing networks for low-resource devices that operate effectively even when their power supply is compromised. By 2035, technological dominance and absolute data sovereignty will be the primary currencies of national defense. Look ahead to 2035. The goal is a resilient, technologically dominant UK, powered entirely by the integrated systems we've just outlined. This document proves the strategy is already in motion. The perfect alignment between the government's objectives and C-IoT's engineering capabilities has opened a rare, massive window to secure major R&D grant funding. These 4 frontiers are deeply interconnected. Breakthroughs in nanomanufacturing will power life sciences. And secure communications will power defense. Siloed research will not win this level of national funding. Only massive, cross-disciplinary moonshot projects are going to succeed. To the university faculty, researchers, and center directors watching this, consider this an invitation to bring your specific expertise to the table. These upcoming workshops represent the foundational drafting sessions for the next decade of UK technology. Join the C-IoT workshops. Take your niche capabilities and translate them into the national solutions the government is asking for. The blueprint for 2035 is fully funded. The architectural foundation is already built at Southampton. Now it's time to build the future.